Division of polynomials. Now, you should have actually done, if you took 092, you should have done this in the current 092. In the 092, that will be in the fall, because they're going to be starting to test the modules, these things called modules. It's been taken out of the new 092, but if you had the old 092, you probably already saw this. I know that since I'm going to be working with a regular textbook for my online 092, they're going to cover as much as the old 092 did. And once they move to the modules, I don't know whether I'll be moving to the modules or not, but at that point I might be done with 092. So, but division in algebra is basically almost the same as doing division in arithmetic. And if I take a look at division in arithmetic, if I say I want 15 divided into 23/15, the first thing I would say is 15, and then I'd move over. It doesn't divide 2, but it does divide 23. Divides 23 once, and then I take 1 times 5, and it would be 5, and then 1 times 1, which would be 1, and what would be the next step in the process? I'd subtract, which changes the signs. We never thought about doing that whenever we were actually doing the arithmetic part. We just said subtract. And this would give me an 8, and then I'd bring down the next digit, which is a 1, and then I'd say 15 divides 81 5 times, and I do the same thing. 5 times 5 is 25. 5 times 1 is 5, add 2, 75. Then I would subtract, which changes the signs. That brings down then a 6. And then I bring down the next digit, which is a 5. 15 divides 5, we'd say 4 times. Then 4 times 5 is 20. 4 times 1 is 4, add 2, 60. Then you'd subtract, which changes the signs. You'd end up with a 5. Because there's nothing more past this 5, what's left is the remainder. A remainder is going to be a number smaller than your divisor. In this case, I'm with a 5, and then that's 15. So how would we write our answer? Well, we would be used to writing our answer as 54 and 5 over 15, the remainder over the divisor. If we think about expanding this, if I was on the number line, I go 154 units, and then I'd go an additional 5 over 15 units on the number line. That's one of the ways that we would write this using algebra. Or the lazy way of writing it is 154 with a remainder of 5. In algebra, we tend to use these two, depending upon what we're doing.
We don't reduce it?
Hmm?
We don't reduce it to 1/3?
Yeah, you could reduce it to 1/3, yeah. But in algebra, you'll find when you're doing division, you usually don't have to reduce the remainder.
Okay.
So, how does this then relate to doing long division in algebra? Well, the difference between long division in algebra and long division in arithmetic is, one of the things is, here, what I was always looking for is I'm reducing down essentially the size of the number. So, and I look at down here, and the 5 is smaller than my divisor. Here, I'm going to be reducing down, but when I'm reducing down, I'm looking to get the degrees down, okay? So I start out with what I'm dividing into being of degree 2. My divisor, highest power to the peers is 2, so it's degree 2. My divisor is an x plus 1. Highest power to the peers is a 1, so it's degree 1. That means when I get a remainder, the remainder has to be smaller in degree, because we're not talking about numbers now, we're talking about letters, smaller in degree than the divisor. If the divisor is degree 1, I know I have a remainder when I end up down here with degree 0. Well, what's the degree 0? Degree 0 is a number. Because what's attached to, say, would be a 5, would be a 5x to the 0 power, but we know x to the 0 power is what? Is 1, so that's just a 5. So in this case, if this is degree 1, I know I'm done when I'm left with just a number, and that number is degree 0. This is degree 1. I know I'm done. Now, what division is continuous subtraction, because you're reducing things down to get smaller and smaller until you get down to its smallest piece. What multiplication is continuous addition. And I learned that whenever I was learning all these times tables. And I was having a heck of a time remembering 6 times 7. But I could remember 6 times 6. So if I looked at 6 times 6, I knew that was 36. If I looked at 6 times 7, here I have 6 sixes, here I have 7 sixes, I have one more 6 than I had in the one above it. This would be 36. I have an additional 6. That's 42. That's how I would get to 42, because 6 times 7 is an additional 6 over the one above it. 56 was another one I had a problem remembering. 56 is 8 times 7. But what could I remember?
8
Yeah.
8, 64.
8 times 8, 64, but that's too big.
7.
See, if I'm looking at, okay, I need to find 8 times 7.
Is 48.
Yeah. Could I remember what 8 times 6 was?
Yes.
And 8 times 6 is 48, and what 8 times 7 would be 48 plus an additional 8, because I'm dealing with 8s, which then turned into 56. So that's where I began to learn that all multiplication was repetitive addition. If I got stuck in one place, if I started where I was stuck and continuing to add the same number, I would eventually get to where I needed to be. That was always plan B, but on an exam we get desperate. So what's that going to do for us? Well, if division is continuous subtraction, why? Because we would subtract at each level. What do I need to do? Well, I would say to myself, and now that I've written over this thing, which I shouldn't have done, I would say to myself, I need to reduce down the degree. And in order to get the degree reduced down, I have to get rid of that 2x squared. And I'd say to myself, what do I multiply x by to get 2x squared? Well, I would say x times something equals 2x squared, and you would say it would be what?
2x.
A 2 and an x. Two x times x is 2x squared. 2x times plus 1 is plus 2x. What's the next step in doing any division? You would subtract. Now, what does subtraction do? It changes the sign. So if this is a plus, it changes it to a minus. This is a plus, it changes it to a minus. The x squareds drop out. I've now dropped it from degree 2 down to degree 1. And this becomes an x minus 1. And then you bring down the next term. And then you would say, what do I multiply x by to get x? So x times something equals x. What's that something? 1. So since this is a plus x, this would be a plus 1. So now you do the same thing. 1 times x is x. 1 times plus 1 is plus 1. Now I subtract, which changes the signs, and I end up with a minus 2. So what's my answer? My answer can come in several forms. 2x plus 1 with a remainder of minus 2. That's my favorite. 2x plus 1 plus the remainder over the divisor. Sometimes in calculus, that's what I have to use. Either one of these would be an okay answer. Now notice I did not write over top of the existing sign. And the reason for that is it keeps track of whether I've changed all of the signs, because they all have to be changed. And it maintains the identity of the original sign, so after I have to go back and check, I can check without having to redo the problem. One thing I always make sure of, make sure all the powers are accounted for. X to the 3, x to the 2, x to the 1, constant. If it's not, I'm going to have to put a placeholder in, as you'll see in the next example, or the last example. So I'm starting with a degree 1 divided into a degree 3. That means that I won't be done when I come down with a degree 0, which is a constant. So I start off, what do I multiply? Two x by to get 4x cubed. It says 2x multiplied times something is 4x cubed. And what am I multiplying by? 2x squared. That says this is 2x squared. And by the way, I don't care whether you put it over the x cubed or whether you put it over the x squared. Some instructors want you to write it over the power that it matches. I don't care. Put it in between. You know, just get it right. So 2x squared times 2x is 4x cubed. 2x squared times plus 3 is plus 6x squared. And then I do what? Subtract, which changes both signs. Cubes drop. So I'm now reduced this down a degree. This is a 6x squared. Bring down the next term, which is 7x. And then I'd say, what do I multiply 2x by to get 6x squared? You would say 3x. So since this is a plus 6x squared, this would be a plus 3x. 3x times 2x is 6x squared, because remember that's a plus. And 3x times 3 is a plus 9x. Then you subtract. Now the squareds drop. So now I've dropped another degree. 7x minus 9x is minus 2x. Bring down the next term. What do I multiply 2x by to get negative 2x? You would say negative 1. Negative 1 times plus 2x is minus 2x. Negative 1 times plus 3 is negative 3. Then I subtract, which changes the signs. 2x drops. Minus 3 plus 3 is 0. I have a remainder of 0. So my answer is just 2x squared plus 3x minus 1.